Okay, so hi everyone and welcome to Scylla Monster Summit. I'm Zach Livetan, VP Product at ScyllaDB, and we are thrilled to have two exceptional guest and engineer for a Q&A session. The first is Martin Kleppmann. I will let him introduce himself later, but I would say that I'm following his work for years, especially for those who are familiar with this book. I have a hard copy and not in the best shape. I guess I'm looking for the second edition to buy a new one, but I've read it many times, not always end to end. I usually go to the LSM part and SS table, which is more relevant to me personally, but I did read it, all of it, and it's great. So I'm very excited to hear you guys are working on a second edition. And second, we have here Chris. Chris is a co-author of quite a famous book which called The Missing README, which talk about engineering in general. I highly recommend software engineer to read it. And both of them have did a lot of work in different topics. We're going to touch part of it in this session. So hi guys. Did I miss anything from your introduction? Just let me know.
Well, hello, thank you for having me. Yes, I'm Martin Kleppmann. I'm currently an associate professor at the University of Cambridge. And I also wrote this book, Designing Data-Intensive Applications, a couple of years ago. It came out in 2017. And right now I'm working on a second edition of that together with Chris.
Hey everybody, I'm Chris Riccomini, and I do a few different things. I'm helping Martin write the second edition of Designing Data-Intensive Applications. I also run a small investment fund called Materialize View Capital, and I write an infrastructure newsletter also called Materialize View, appropriate name given our conversation topics. And then I also contribute and run an open source project called SlateDB, which is an open source object storage based LSM, so kind of like RocksDB, but built on top of object storage. So those are kind of the 3 or 4 things that I keep myself busy with.
Thanks, Martin and Chris. So before we dive into the more technical question, just if you can give us how did you guys met and started collaborate, and how many years was it? So go ahead. Whoever want to answer it, just go ahead.
Yeah, I think we met in probably 2013 or something like that, I would guess.
Sounds about right. Yeah, we were both at LinkedIn, right?
Exactly.
Yeah.
Yeah, so Chris was working on the SAMSA team at LinkedIn at the time, developing this large-scale stream processor. And I had joined LinkedIn through the acquisition of our previous startup and was in the process of switching teams. And then I found the folks working on Kafka and SAMSA and thought that's really exciting. And so asked whether I could join that team. And so then I got to meet Chris that way.
Yeah, so on my end, I think Martin and I worked on SAMSA. I can't remember how long. It was right before you left, actually, I think. So maybe 6 months or something like that.
Yeah, not very long at LinkedIn.
Yeah, long enough to add some chunks to the code, though. And then I remember as you left, you emailed me some draft chapters for a book you were working on, which was like some of the first draft chapters, I think, of designing data-intensive applications. Do you remember when you started writing the book?
While I was at LinkedIn, in fact, I got a bit of time off from LinkedIn.
Yeah, you were on sabbatical, right?
To write it on work time, yes. And then I realized that being a software engineer and writing a book at the same time was not really compatible. And so then I left LinkedIn to focus full time on the book writing.
Yeah. The only way I think I pulled it off was because of COVID. So I had no commute anymore. So I just wrote during my commute time.
Sabbatical are a great idea. So, what triggered you guys to start writing the second edition? Because I know that many people ask for a second edition for a long time. And especially in the industry, things are moving so fast. So something that was written 10 years ago, some parts are still relevant for sure, and I can be evidence of that, but some part maybe got old. So, but what did you took another sabbatical, or was it something else?
Yeah, well, I think I've long wanted to do a second edition, but I also have a lot of other things that I want to do, and it's always a matter of prioritization. But in the end, I felt that technology had moved on enough. Most of the book, tries to focus on the fundamental concepts, which actually don't change that quickly and change on the time scale of decades, not months. And so in some way, I think it's a kind of a nice book to revise, because actually there are not that many big changes. But at the same time, a lot of details have changed. And I would say the biggest is probably that the way people use cloud services nowadays has changed a lot compared to 10 years ago. Of course, cloud existed 10 years ago, but I think the impact that it's had on data systems architecture has only really been felt in the last few years. And so that's something that we're really trying to work in throughout the second edition of the book.
And so you mentioned cloud as the biggest change that drove you to write, but if I can, a quick follow-up on that. So, and I'm drawing from my own experience with ScyllaDB. So ScyllaDB, like many other projects, we are not unique in that we have an enterprise standalone edition, and we are also offering the database as a cloud service. Other databases like DynamoDB, for example, have only a cloud offering. So my question is, the fact that the database running on the cloud affect the internal architecture of it? Does it allow you to do other things, or is it basically the same with an API on top of it?
Do you want to take that first, Chris?
Yeah. So this is something I've been thinking a lot about. I think there's another edge of that question, which is on the embedded and client side, and seeing a shift towards databases there as well. And so I think to expand that question out a little bit, it's more like, has database architecture changed now that we're putting databases in more places, whether that's cloud, whether that's BYOC, on-prem, on client, on edge, right? And I think the answer is yes. I kind of have this hypothesis that the successful databases of the future will be ones in which they can move or scale with you from, on your laptop to on your server to in your cloud to in another cloud. And I think we're seeing evidence of that across things like DuckDB and MotherDuck as a sort of example from embedded to cloud-based. I think PG-Lite and Postgres is another example of that, where they're embedding Postgres. SQLite obviously is a signal there on the embedded side. On the query engine side, you see it with things like Daft, where they're able to run, embedded locally. I don't think they run embedded actually, but they run locally. But they also run distributed as well. And so I think the answer is yes. The biggest shift is sort of a split between control, data, and compute planes. I think that architecture has sort of been widely accepted now and is showing itself to be pretty flexible when you shift between SaaS and BYOC. On the other hand, there's sort of an operational aspect to this when you talk about SaaS versus non-SaaS, which is multi-tenancy and being able to leverage a lot of the stuff that the cloud provider has. Sort of an interesting discussion I had with some folks around Confluent Freight versus WarpStream, which are two kind of competing Kafka streaming systems. And Freight is built to leverage all of the in-cloud SaaS stuff that Confluent has built, whereas WarpStream is built much more like a BYOC system, where they don't take advantage of, for example, a custom network plane that Confluent has. And so I think operationally, there's a lot to consider around security, multi-tenancy and stuff as well. And I'm not sure we're as far along on that curve. It seems like a lot of what SaaS companies are doing is still like proprietary and internal. So that's sort of my read on the situation.
And I might add a little to that. So in terms of how it affects database architecture, my feeling is that, like, at the time of the first edition, the model for databases was like, there's a node running on a machine, it stores data in its file system. So storage is on local disks on a file system. That's your storage abstraction. And then if you want replication, that happens at the application layer on top of it. And now we're increasingly seeing this model where actually storage is an object store, for example. So it's not a local file system, it's a remote service. It's already replicated. And so the properties of building on top of an abstraction like an object store just allows you to do totally different things compared to this local storage of a local disk. And I'm not saying that like one is better than the other. There are always trade-offs with these things, but it's definitely like a new a new point in the trade-off space that has been added, which at the time of the first edition wasn't really a thing yet. Of course, object stores existed, but I don't think as many databases had really taken advantage of them in the way that people are doing now.
Yeah, thanks. Definitely, we've seen more and more database using S3 in particular. If I can give an example as a backend, and I can tell you, spoiler alert, that we are looking at ScyllaDB. We're looking to do the same, and of course, it's come with latency and other prices that you need to take into account. I can also share a little bit from our experience that when we started Scylla and created the Scylla standalone, we are trying to do our best to make the installation very simple, to make the database as simple as possible from operational perspective, because we knew customer need or user need to manage it themselves. So we didn't want to create, for example, many different type of nodes and things like that. On the cloud, we can do whatever. We're responsible for it. We can have 16 different type of nodes, and we can basically push all that under the rug and no one will know. You just consume the API. So we can be, if we want to, we haven't gone all the way, but we can be more flexible on that. Thanks, that was very interesting. And Chris, what you mentioned earlier about edge databases, which we can use in different places, bring me to another question about specialization. Something that I'm looking at always in, not just in databases, in all technologies, there is like specialization and then unification, if you want to call it, or something like that. You mentioned one dimension, edge versus backend, but there are, of course, other dimension like analytic versus real time, or in the past we've seen a lot of type of databases, and we still see that actually a lot of type of databases all over the place, vector database, graph database, etc. And do we see this trend continue, or are we on the way back for consolidation? What's your view on that?
Chris?
So yeah, this is sort of with my investment hat on, the $1 million question or $1 billion question is which of these is it? I think the answer is probably both. The reality is Postgres is really kind of taken the world by storm lately, and especially its extension ecosystem have really shown to be pretty robust in the later versions. And so for most people, when they're starting to build out, just naturally, they're going to build with something like Postgres, and they're going to use PG search or something like that for their search index. They're going to use PG vector for their vector embeddings. They're going to use PG analytics or PG DuckDB or one of those kind of systems for their data lake. And then the question is sort of, as they scale, is that still going to be okay? And I think probably in some cases, yes, and in other cases, no. My personal hypothesis is that as you not only scale up, but need specific features that are core to your product, you're probably more likely to move to a specialized system. So for example, with something like PG vector, that's probably like a reasonable place to start. But if your entire product is like Cursor AI or some IDE where you're doing code completion, you probably need something a little bit more robust and scalable than what you're going to get from PG vector. And then they would probably look to something like, Pinecone or TurboPuffer or these kind of companies. So I think it's a both and. I do think because PG vector is going to kind of Postgres is going to eat the bottom of the market, that there's going to be fewer vendors that are specialized, but I think they're still going to exist. So that's sort of my read on the situation.
Okay, thanks. I'm taking it in a slightly different direction. So both of you worked on streaming projects and not just on databases. So first, as a first question, like, what's your view? I'm more familiar on the database side, so I know database guarantees, like NoSQL versus SQL. Each database have a slight different guarantees versus performance trade-off, if I can, from a very high level. Is that the same that you see in the streaming space with the different project, or are the trade-off different there?
I think it's another one for you, Chris.
So, there are, I think, a few different sort of fundamental trade-offs that you wrestle with in streaming. One of them is consistency, right? So with stream processing, you want to do something called state management, which is essentially as you're doing aggregations or joins, you need to be able to like pile data up and then emit it periodically. And depending how you pile up and emit data, you can like emit duplicates, you can potentially lose data. And the trade-offs there kind of come with different levels of complexity in the implementation of a stream processing system. Sorry, this is a bad answer. Let me think about this one for a second. I don't know, Martin, what do you think the trade-offs are? So one is definitely latency, latency versus throughput. One would be, I think the state management one like is a recovery time issue. Like you have state, if you co-locate it locally, again, you have faster latency, but recovery then becomes expensive if you fail over. Am I missing anything? What other trade-offs?
In the sort of streaming to databases comparison, there's how to put it? There's this sort of streaming has this slightly weird space, this weird position where like a typical stream processor is this sort of one record at a time callback based API. It's very imperative. And then you could build, for example, relational operators and query plans and stuff like that on top of it. But then if you take that to its logical conclusion, the end result ends up looking much more like a database with incremental view maintenance. And there's like some projects like Materialize, I guess, aiming in that direction of you just give it a SQL query, for example, and then the fact that it's streaming is sort of almost an implementation detail that gets hidden away a bit. So I don't know if that means that the end result for a lot of these systems is likely to be that, well, if you have like a query that you can express in a SQL style, then you could hand it off to one of these systems that does the view maintenance. And then what we currently think of as streaming with the lower level API ends up being used maybe for a more specialized set of applications that either dealing with very high scale or types of queries that are just not good to express in a relational style.
Another thing I would add there is I think the fundamental trade-off between latency and throughput that a lot of these systems wrestle with. And with most streaming systems, ideally you want the lowest possible latency, but of course, if you do that, it becomes harder to maintain higher throughputs. And the way to get higher throughputs is to batch up writes. But as soon as you start batching up writes, then you start increasing the latency between when a message is sent and when it's received. And so, to your original question around trade-offs and consistency and stuff in databases, I think latency and throughput are a big one for streaming and stream processing.
Okay, thanks. Circling back to the book, so you mentioned database as a service of the cloud as one of the things that changed in the last 10 years. What would you guys find as the most challenging part in the revision to write about? Maybe different answers from each.
I don't know if it's the most challenging, but generally what we're trying to do with the second edition is just polish it throughout. So it's very much like an update of the content of the first edition. So the structure, high-level structure, is staying very similar to the first edition. But there are just lots and lots of little detail places where either the information is just a little bit outdated, or we feel we could make it clearer by moving things around a bit. Or where maybe I actually slightly misunderstood something first time and got something wrong, and so this is an opportunity to correct it. And so this is that's kind of the approach we're taking with it. So I think if you hold the two side by side and actually compare them line by line, you'll notice that quite a lot of text is changing, but the sort of high level ethos of the book is staying very much the same.
I think on my end, the most challenging thing is sort of how to not be too invasive and put stuff in that maybe doesn't fit. Sometimes I find myself, I have pet hobby horses or find something really fascinating, but then can't really find exactly where it should fit within the structure of the book. And knowing when to say no and when to cut stuff, I think is maybe not challenging, but something that I'm certainly cognizant of. It's it's an important book, and I don't I want to have a light touch on it, I guess is what I would say.
And it's quite big already, if
Yeah.
I'm
Yeah.
not as a criticism, but a lot of information. So yeah.
Yeah, and we really don't want to add another 200 pages to it. I don't think anyone wants that.
Can I ask from a technical perspective, what has changed in technical writing since you wrote the first edition? Are you still using the same editor and tooling, or have you moved to Git and some cloud magic?
So tooling has stayed absolutely the same, actually, from my point of view. So already for the first edition, O'Reilly had quite a nice tool chain where we write ASCII doc files in a Git repository, push the Git commits to a cloud endpoint, and then there's a web interface that we can click to generate a PDF. And they already had that 10 years ago, and it's still the same system and still working well. So in terms of that way, the writing process is fine. And then for collaboration between Chris and me, we're just using pull requests on GitHub. It's like a software project. We review each other's patches. We use the usual Git commenting features, and actually it's pretty nice.
Yeah, I would add, I think O'Reilly's tool chain for software engineers is pretty top notch. It's pretty pleasant. I think other publishers don't always operate under similar tool chains. So that's been a real breath of fresh air for me. Maybe hidden somewhere deep in this question is like, has AI changed the way that you write?
That's my next question for sure.
I mean, for me, no, I don't really use AI to actually write anything. I think what it's really helped for me with is research and understanding. I'll ask, which distributed data systems use eventual consistency, and it can spit out a list. And then I can I don't think I ever take its word for as truth. I have to then go and make sure it's not hallucinating, but it gives me a nice, easy starting point for a lot of stuff. So I think where I mostly use it is more in kind of like the research and exploration phase. And then I synthesize that stuff myself.
Okay, thanks. And I have to ask, how do you see database affected from AI? Not necessarily how to write a database, but would you see, like, we've seen, of course, vector search as a feature that most databases are added. There are some specialized vector search databases. But do you think it's that it? I guess AI is just starting in a sense. So how database will change to match AI requirement, if you can be like a science fiction author for a second and imagine the third edition of the book in 7 years, how would it look like?
So there's some sort of AI plus data work that we've been exploring in some research, which is not really part of the book. But the idea there is, if you wanted to say, given AI control of some system, so it's allowed to press some buttons for you, which may, affect some data, like allow it to edit some data, update some data, for example, then it seems that the safest way to do that is to give the API a well-defined interface, so that essentially the buttons it can press correspond to things that actually make sense and like maybe fulfill certain consistency properties. So it seems to me like having interfaces that allow AI agents and humans to safely compute, and using a database as the common ground on which they interoperate. By humans can update some data, the AI can update some data, they can see each other's changes, maybe review each other's changes, decide when to merge them in. Those types of processes, I imagine, will be necessary if we want to have good collaboration between humans and AIs.
Yeah, I think in terms of implementation details, so to speak, the storage formats are going to evolve for sure. I think we're seeing that with systems like LanceDB, where they're trying to address multimodal data. I think also Arrow, which is kind of built for columnar stuff, maybe not the best fit for some of these multimodal data sets as well. And that extends beyond storage into things like Arrow RPC. So then the question is there, do we need some kind of equivalent for multimodal data? I think on the query engine front, an interesting avenue that's been pursued for a long time already, but probably will continue to evolve, is query optimization, indexing, essentially like smart DBs that are running themselves using AI to sort of look at query patterns and adjust on the fly. There was a really good paper a long time ago just using more traditional ML techniques, I believe from Google, that talked a lot about essentially dynamic indexing based off query patterns. So that would be another one. And then, of course, sort of support for embeddings and vector search, semantic search kind of stuff will definitely happen. RAG is another one. So some kind of good integrations with RAG, I think, is something that is useful. I think we're just at the forefront of this stuff, so it's kind of tricky to know. I think as with everything, right? Everything has changed because of the AI stuff, and the same is true for databases. So it's a little bit hard to figure out what to integrate into the book. I think we did add some semantic search and embedding and vector search stuff, but very light touch. There's like one or two sections here and there. So.
Okay, so thank you guys very much. I think we fill up all of our time, but before we wrap up, I had a lot of other questions about privacy and how it's related to the cloud trend that you mentioned earlier, and edge computing, which Chris you mentioned. So there is a lot to talk about, but maybe we can have another talk at the next event. I will be very happy. Anything that you guys want to take this opportunity and promote, which is not just the book itself, which again I highly recommend, but maybe some other interesting thing that you guys read or another event that you want to highlight, if there is any.
Well, I could mention this line of research that I have going on something called local first software. So that's a sort of new philosophy for building applications where essentially we're trying to deprioritize the cloud and move things much more to the end user's client. So it's edge really in the sense of the end user's device. And the idea is that if the user is creating some files, be it text files or spreadsheets or graphics documents or things like that, they should really be stored primarily on the user's own device and then only secondarily have a backup and a syncing service in the cloud. And this is a really fascinating idea because it really changes the way that we think about data systems architecture to put the client first, not the server-side storage first.
I think on my end, I would just highlight the Slate DB project I mentioned at the beginning, which I think is just kind of a really fascinating application of a whole bunch of stuff we've just talked about. It's using object storage, it's using a log structured merge tree as its file format, it's an embedded key value store. We're in the process of adding transactions, and so it's open source. We're looking also for users, but contributors as well. We've got folks contributing from Responsive, from Confluent, and from a number of other companies, DataBend, and so on. So if you guys are interested in applying some of the stuff from the book, I think SlateDB would be happy to have you.
Great, and we can probably add links to both this somehow to the show notes, or I don't know how it's working. And by the way, Martin, it's remind me many years ago there used to be like a discussion about fat client and thin client. So everything is new and everything is old in tech, I guess, because we are getting back on the circle. Yeah,
I think we're definitely moving back towards the fat clients.
Yeah, for sure. I think object storage, I think we're just riffing here, but I think object storage is really helpful in that regard, because you can interface with object storage from basically anywhere. And it can provide all the replication and durability you need. So you can kind of just use it as like a bus to ship data back and forth. So it's opened up a lot there. Privacy is, I think, also sort of at the forefront of a lot of people's minds. And then just the latency characteristics you get for the products, right? Because they all seem magically there. And I think all the whole Jamstack movement kind of pushed in this direction as well. There's just so many trends and sort of tailwinds in that regard that it seems inevitable at this point that we're going to be spending 10 years with fat clients.
Okay, so definitely I will check out both of these projects. Super interesting. And at least, Chris, I'm following you on Blue Sky, which is another interesting project that uses Scylla, but we're almost out of time. So thank you, Martin. Thank you, Chris. It was very interesting for me.
My pleasure. Thank you.
Thank you too.
Thanks.
Yes.